Hello everyone, this is Mr. Kozlowski and welcome to Unit 3 Forces. Today I'm going to be talking about Newton's second law of motion. This is learning target number 4, and basically learning target 4 states that students can understand Newton's second law of acceleration and can apply it to occurrences in the everyday world. Newton's second law states if forces on an object are unbalanced, the object will accelerate. The rate of acceleration will depend upon the mass of the object and the amount of force applied. Basically, this translates to force equals mass times acceleration. This is an equation where we're going to have to understand not only conceptually, but also make calculations here, and we'll practice that in class. In terms of what we need to know conceptually, there's a few things. Number one, again, the acceleration of the object will depend directly upon the net force acting on the object and inversely upon the mass of the object. That word inversely is something new. I'm going to explain that here in just a few moments. So basically, as force acting on an object is increased, the acceleration will increase, and then that inverse relationship will kick in with the mass. As mass increases, the acceleration of the object will decrease. This can be explained in a simple flow chart. Again, if we have an unbalanced force, there's going to be acceleration. The acceleration is going to depend directly upon the net force, so more net force, more acceleration. And then the acceleration will depend inversely upon the mass, so more mass, less acceleration. Now, how can we show that? Well, here is an example of the equation, F equals ma. This is the pyramid. And then also, if you want to go to this PhET and check it out, you're more than welcome to. Speaking of the PhET, let's check it out right now. Here's the PhET diagram or PhET simulation. And what we're going to do is talk about those two concepts. The first one was if we increase force, you're going to increase acceleration. So let's look at this. We're going to have a little bar here for acceleration. And then we're going to have the values and the sum of all the forces. So right now we have some friction, and I'm going to use friction to show you an unbalanced force here. Right now we have balanced forces. If I keep increasing it, you can see that the box is not moving, and we need to get to a point where the force is unbalanced. So if you can see here, we have 150 newtons applied force, which is 125 newtons of frictional force. We have a sum or unbalanced force of 25 newtons in this direction. As you can see, the acceleration has increased a little bit here. If we continue to go up, you can kind of see that the acceleration is going to increase, and this shows the relationship between acceleration and force. The more unbalanced force we have going in a direction, the more acceleration. So as you can see right there, that would be the first concept. More force is going to, if we increase the force in F equals ma, you're going to have more acceleration. The inverse relationship is mass. So what we're going to do here is we're going to place a mass. As you can see, the mass is this was 50 kilograms and this was 50 kilograms. And then we're going to look at the forces here. And again, we need an unbalanced force to move this large massive object. So if we have more mass, it's going to impact the acceleration inversely. So that means if more mass, less acceleration occurs. So what we need to get this object moving is we're going to need more force. So as you can see, applied forces are equal. We have more mass. We're going to have less acceleration. And as you can see, the last time we applied 150 newtons in the first time, that would start the acceleration of the 50 kilogram box. But now we have 2. So once we get to 300, we're now going to have a net force and acceleration. So again, it inversely impacts acceleration. The first time around, we had 150 newton force for one box. Now we need 300 newtons for 2 boxes. So just to get the same amount of acceleration for one box. So as you can see, that's an inverse relationship. If we increase the mass, there's definitely going to be less acceleration with the same amount of force applied. to get acceleration. In this case, we need to double that force. And as you can see, it's accelerating. As I keep going, so does the acceleration. It increases as well. So to review, there's a few things you should be aware about. Okay, here's some videos. I'm going to post links to this. All right, you can look at more of the conceptual stuff of Newton's second laws, and you feel free to use those. I will be using these examples in class as well. And then also there's some quantitative practice. Here are some problems. You can pause the video, practice calculating some of these forces. You'll get plenty of time to calculate forces as well. But I'm also going to post a link to these answers as well. And then here's one more for you. Again, this is Mr. Kozlowski. If you have any questions on Newton's second law, feel free to contact me or rewatch the video. And again, make sure you take good notes. Thanks.